Believe it or not, math is art. I know this might be a little hard to believe, but just like all of our favorite artists can use lines, shapes, and colors to create magnificent works of art, mathematicians can use numbers to describe these very beautiful things. So let's start our masterpiece the same way any artist would, by drawing a line. Here, we have a Cartesian plane with the horizontal x-axis and the vertical y-axis. Let's calibrate both axes in increments of whole numbers. Remember, when drawing your graphs, don't be a lazy bones like me. Please use graph paper. This way, you can ensure that the numbers on the x-axis and the numbers on the y-axis will always be evenly spaced. Using graph paper, your graph should look something like this. Now, let's draw the simplest line we can possibly have. The line y is equal to x. We can see here that y is equal to x is among the simplest of equations, where all the y values would be equal to the x values. So any value of x would be equal to its corresponding value of y. It is said y equals x is an equation where y is expressed as some function involving x. In this case, y happens to be equal to x. To draw any line, all we really need is 2 points. Once we have any 2 points, we can draw a line. Let's see how this line y is equal to x will look on graph paper. As we can see, the line cuts the Cartesian plane exactly in half, where every x value is equal to the y value. If we wanted to draw this line, we could choose any 2 x values and find their corresponding y value. Once we have 2 points, we can draw any line. But what if we wanted to change the line somehow? Well, let's start by changing the equation. Let's add a number. Let's add 1 to make it y is equal to x plus 1. Now, x plus 1 is a function involving x. Therefore, y is a function in x. Let's see how y is equal to x plus 1 will look as a line. The first thing we would need to do is to choose our 2 points. Remember, we only need 2 points to draw any line. So, let's choose our points. Remember, we can choose any values of x that we want. So let's choose the first value of x to be 1, and therefore we will get 1 plus 1 is 2. How about we choose the second value of x to be 6, and therefore 6 plus 1 is 7. When x is 1, y is 2, and when x is 6, y is 7. Now, we draw a straight line through the points, and we have the line y is equal to x plus 1. Notice that this new line cuts the y-axis exactly at 1. That's very interesting. Now let's redraw the line y is equal to x, just to compare and see the difference between the two lines. What do we notice? We notice that by adding 1, we actually shift the line 1 space upwards. That is quite interesting indeed, because now, by adding a number, we learned that we could move the line up or down. So let's find out what will happen if instead of adding a number, we subtract a number. Let's see if we could draw the line y is equal to x minus 1. To draw the line y is equal to x minus 1, all we need are 2 points. So let's choose x to be 1, so 1 minus 1 is 0. And let's choose our other x value to be 7, therefore 7 minus 1 is 6. And so we have 2 points, 1, 0 and 7, 6. Now, with those 2 points, we can draw our line y is equal to x minus 1 and see how it compares to the other lines. Now let's check back on our graph paper and see how all 3 lines look together. We can see the line y is equal to x right in the middle, where the line y is equal to x plus 1 being 1 space above, and y is equal to x minus 1 being 1 space below. We can notice that by subtracting 1, we actually move the line 1 space downward. So this is very interesting indeed. We learned that if we add 1, the line moves upwards, and if we subtract 1, the line moves downwards. So we see here that by adding or subtracting a number, we can actually make the line move. But what if we decide to multiply a number? Let's try y is equal to 2 multiplied by x, or y is equal to 2x. Well, like any line, all we need are 2 points. Remember, we could choose any points. So let's choose x to be 1, so 1 multiplied by 2 means y is 2. And let's choose x to be 5, so 5 multiplied by 2 means y would be 10. So we have the points 1, 2, and 5, 10. Let's draw this line and see how it will look. That's very, very interesting. One thing we notice is that the line is steeper when we multiply by a number. So therefore, multiplying by a number actually gives us the gradient of the line. It affects the gradient in such a way that we could now make the line more steep or less steep. What if, instead of multiplying by a positive number, we multiplied by a negative number? How would that affect the gradient of the line? So, let us consider the line y is equal to negative 2x. The first thing we would need to do is find our 2 points. Remember, we only need 2 points to draw a line. So, let's try when x is 1, y will be negative 2. And how about when x is 5? Well, then we see y is negative 10. We've come upon a problem though, that our Cartesian plane here does not have negative numbers. We've only drawn the positive portion of the Cartesian plane. So now we have to redraw the Cartesian plane to expand it so that we could see where these negative numbers are. We can see here that if we put the positive numbers above 0 on the y-axis, obviously the negative numbers will be below the 0 or the origin point. Now, we have a Cartesian plane where y has negative values. And so we could now draw our line when x is 1, y is negative 2. And when x is 2, y is negative 4. Let's use that instead. And now we have a line with negative gradient. Notice how it's slanted in the other direction. This is what a negative gradient looks like. And it occurs when the number multiplied by x is a negative number. So to recap, a positive gradient is usually slanted to the right, whilst a negative gradient is usually slanted to the left, and is determined by a positive or a negative number being multiplied by x. So now, what if we choose to combine all of these methods? Let's multiply a number by x as well as add a number to x. So how about let's try to draw the line y is equal to 2x plus 1. Well, we draw this line just like any other line. The first thing we need to do is find our 2 points. Let's use the points when x is 1. We see that 1 multiplied by 2 is 2 plus 1, y will be 3. And when x is 3, y is 7. So let's redraw our Cartesian plane, and I'll be a little careful this time to make sure that I calibrate it evenly on both the x and the y-axis. There, that looks a little better than the last one. And now we have our 2 points, 1, 3, and 3, 7. So we could see here that a combination of things happened. Not only did the line shift upwards and is intersecting the y-axis at 1, but it also got steeper as well. So we see here that by adding a number, we are actually finding where the line intercepts the y-axis. And by multiplying a number by x, we are changing the gradient of the line. We can make it steeper or less steep, depending on the size of the number we multiply. So let's mix things up. Let's multiply by a negative number and subtract a number at the same time. We saw that when we subtract a number, we should expect the line to move down. And we saw that with a negative gradient, the line should be slanted in the other direction. So, how about you grab your graph paper and try to draw the line y is equal to negative 2x minus 1. How about you try to pause the video, and we'll wait for you, don't worry. Go and draw the line, and then when you press play, we will show you what the line looks like. Nice. So hopefully you got something looking like this. And we could have predicted that the line would have cut the y-axis at negative 1, and it would have been slanted to the left because of its negative gradient, minus 2. Now, isn't drawing lines fun? Imagine we could draw all sorts of lines and shapes using numbers and equations, so we could see how math is art. Do you think that you could make up your own lines and therefore your own shapes? Maybe you should experiment and have a lot of fun doing so. Please make sure to check out the exercises in the app. There are a lot more lines there for you to try to draw. And I'll see you all in the next lesson where we talk a little bit more about the equation of a line. Have fun!